Hey, good morning. Good morning, everyone. I'm having several students asking about this problem. Number five, so I decided to, instead of replying to each one, to do it. And so hope you get it. So you have wait a second, let me create the comments first. Okay. So then you have two blocks, and supposedly the object 2.85 right there is held in place on an inclined plane, has an angle of 40 degrees. Coefficient of kinetic friction is given right there. Second object has a mass, which is this one, connected to the first object with the massless string over a pulley that's massless. Calculate the initial acceleration of the system and the tension in the string once the objects are released. So as of now, we don't know if when release happens, if the objects will move, let's say the green object will move downward or upward. We don't know, right? It would depend on angles, would depend on combination of masses. So then we make an assumption. And the assumption is, well, if the green block moves downward like this, direction of motion, then necessarily this block move upward, right? That's the idea. Direction of motion. You could do another assumption. You could say, well, this green block is moving downward, in which case the gray block is moving downward, in which case the green block is moving upward on on the slope. Okay, so I'm gonna go with this assumption. It doesn't matter. So once you calculate everything, if you find a value of acceleration that is negative or a value of tension that is negative, that's sort of weird. It means the direction assumed was not the right one. And then the only thing you do is to reverse directions, okay, if that is asked. So with that assumption, the free body diagram on the gray block is that you have weight, which is m2g. I'm not going to put numbers. And then you have a tension that should be bigger, right? So this is the free body diagram. A free body diagram, when you do a free body diagram, you have to indicate your vectors starting, which means their head should be away from the object, or the tail should be centered, should be anchored on the object studied, this block, right? And any arrow you put outside, you have to define what it is. And I like to do an indication the motion has acceleration is just for me. But this is not part of your free body diagram. A free body diagram is a diagram of forces. So F is a force and is anchored on the object. The weight is a force that is anchored on the object. And the force of gravity is not G. G is just acceleration. The force of gravity is m2g. So let's apply Newton's law to this gray box. So it moves upward. Upward is a positive direction. Then we have tension minus m2g is equal m2a. m2a equal. Okay, so that's our first equation. So put it aside. And then you go to the next one. The next one is a block, is the green block. What are the forces on it? Well, M1G going down, and parallel to the slope, the tension force is there. But also, since the block is assumed to be going in this direction, it means the friction force is pretty much parallel and in the same direction as that of the tension force. This is kinetic friction. Okay, and the normal force should be there. So here's my normal force. Okay, so the sum of forces in the y direction. And what is my y direction? Let me change the color. Why do I change color? Here, perhaps. Here. Oh, there you go. Here's my y-axis. Positive. And here's my x-axis. Positive. Okay. Go back now to black. Okay. Now, sum of forces in y is equal to 0. There is no acceleration in the y direction. So the block is not jumping off the slope. And what we get is normal is equal m1g cos, well, what happened? m1g, oops. I'm gonna write down here. Yeah, so normal minus, so sum of forces in y equals 0. So normal minus, no, this angle is 40, right? So here's the gravity, the direction of gravity force. So this angle is 40. This angle appears right there. So which means gravity projecting the y direction is negative mg cosine of 40, right? Negative because it goes in the negative direction, and the projection of gravity along the positive direction in x is mg sine of 40. That's what I'm going to write here. So in y, that's what we are doing, n normal force minus mg, in fact m1g sine, I'm sorry, cosine of 40. I'm projecting y. Cosine of 40 is equal to 0, which means normal is equal to m1g cosine of 40. Okay. Now, this is interesting because our kinetic friction is equal to the coefficient of kinetic friction times the normal, which means your kinetic friction is equal to that coefficient given times m1g cosine of 40. All right. Now, how do we do the sum of forces in x? Well, sum of forces in x is equal mass times acceleration. Acceleration being a number that is the same as we use it here. And what are the forces projected in the x direction? So we have the gravity force m1g sine of 40, right? Minus the frictional force minus the tension force. And this is equal m1 times a. And here we hit our second equation. This is the second equation, number 2. Number 1 is right here. This is the number 1. So when you add number 1 to number 2, or when you single out tension here, tension is m2a plus m2g. When you single that out and plug it in there, So you have this mega equation, m1g sine of 40 minus fk. What is fk? Is 0.552 times m1g times cosine of 40 minus t, minus t. What is t? T is m2a plus m2g, m2a minus m2g, have a minus applied to both of them, is equal m1a. And then you can find your acceleration, right? You put every body in one side of the equation and then problem is done. So let's do that. Acceleration will be m1g sine of 40 minus 0.552 times m1g cosine of 40 minus m2g, all of this nonsense divided by, so I have a minus m2g right there, divided by m1 plus m2. I think that's what it is, unless I did some silly thing here, but I think that's what you do. So once you find acceleration, you plug it in any of the two equations, 1 or 2, and you have the problem solved. Okay, good luck to you. Let me know if you find something different or I did something mistakenly here. Okay, cool.